You type something into Google and get results back in about half a second, out of billions of pages. Now, here's the thing that should feel strange about that. There's no way it reads billions of pages after you hit enter. It couldn't, not in half a second. So it must have done most of the work before you ever searched. Today we are going to build a tiny search engine that works the same way. It's about 30 lines of Python, and we'll watch it get an answer wrong first, and then we'll fix it. Think about a textbook for a second. If I ask you to find every pages that mentions photosynthesis, you have two options. You could flip through all 400 pages and check each one, or you could go to the index at back, find photosynthesis, and it tells you exactly which page to look at. The index is faster because someone already did the reading. They read the book once ahead of time and wrote down where every word appears. That's what a search engine does. It reads everything in advance and builds an index. Then when you search, it just looks things up. This is called an inverted index, and that's the first thing we are building. We need something to search though, so here are 5 short documents. Think of each one as a web page, just much smaller. Each has an ID number and some text. Then we need a tokenize function. All it does is lowercase the text and split it into individual words. We lowercase so that cat and cat count as the same word. This is the whole index. It's 4 lines. We go through every document and then through every word in that document. For each word, we record which document it appeared in and how many times. So the structure we end up with is a word pointing to a list of documents. Let me show you what it actually looks like. So cat appears in document 1 twice, and dog appears in document 3 once. Now if someone searches for cat, we don't touch documents 2, 4 or 5 at all. We already know they are irrelevant. That's the speed trick, and it's the entire reason search feels instant. Now we need to rank the results. The obvious approach is to just count matches. Whichever document contains the search word the most, it wins. For each word in the search, we look it up in our index. Then for every document containing that word, we add up how many times it appeared. Then we sort highest count first. That sounds completely reasonable. Let's see it fail. So I searched for the dog, and the top result is a document about a cat sleeping on a mat. There is no dog in it anywhere. The actual dog document came second. Here's what happened. Document 1 contains the word the 4 times. Document 3 only has the once, plus the word dog once, so it scores 2. 4 beats 2, so the cat document wins. The word the completely drowned out the word we actually cared about. So let's think about what went wrong. The word the is in almost every document. That means it tells us almost nothing about which document is relevant. The word dog is in exactly one document. That makes it extremely informative. So common word should count for less and rare words should count for more. That's the fix. And it has a name. It's called TF-IDF, which stands for term frequency, inverse document frequency. 2 parts and both are simple than the name suggests. Term frequency is how often the word appears in that document, relative to the document's length. We divide by length so a long document doesn't win just for being long. Inverse document frequency is a measure of how rare the document is across all documents. If a word is in every document, this value goes to 0. If it's in only one, the value is high. Multiply those two together and you get a score that rewards words that are both frequent here and rare elsewhere. The score function is those two ideas, 1 line each. Term frequency is the word count divided by the document length. Inverse document frequency is the log of total documents divided by how many contain the word. The log just keeps that number from growing too aggressively. Then search is almost identical to before. The only change is that we add up scores instead of raw counts. Now the dog document is first. Same query, same index, same 5 documents. The only thing that changed is how we weighted the words. So what we built is a real search engine. Just a very small one. A real one add a lot on top of this. They crawl the web to find documents in the first place. They handle word variations so that running and run match. They factor in how many other pages link to a page, which is what PageRank did. And they consider your location, your history, and hundreds of other signals. But underneath all of that, the 2 ideas we just built are still there. Index everything ahead of time so lookups are fast, and weight rare words more heavily than common ones. That's a working search engine in about 30 lines. An inverted index so you never scan everything, and TF-IDF so the ranking actually makes sense. Full code is in the description if you want to run it yourself. If you want to follow up where we add page rank and rank pages by links, let me know in comments. See you in the next one. Peace.